Yes. Yes.
Yes, Ramesh.
Yeah. So today is day two of Terraform series. Yesterday, what we have covered is yesterday was day one, and we have covered very basics like what is Terraform. We have seen Terraform history. We have seen difference between Terraform, ARM templates, and cloud formation. We have also seen what is provider. Resource, what is resource? I'll be covering today. We did not cover that in detail yesterday. We have seen Terraform init yesterday. So one of the first basic command, and we'll be continuing with the next commands today. And in the labs, we have seen providers declaration. We have run Terraform init. Then we have checked how providers and modules are getting downloaded in .terraform directory. Apart from this, we have also seen HCL log file, terraform.hcl log file. Okay, in day two, so today's agenda is we'll be covering these topics, Terraform basic commands. In it, we have covered yesterday, so we'll continue with the next four basic commands. Those are Terraform validate. We'll be beginning with Terraform validate, then we'll go with Terraform plan, Terraform apply, Terraform destroy. We'll be seeing each one of them what it does when we run these commands. And in the lab, I will be creating a resource on Azure cloud using Terraform using these commands. That's the plan for today. Okay, first one is Terraform validate. So what is this Terraform validate? So basically it checks whether your configuration files are syntactically correct and internally consistent. Basically, when you write the code, Terraform files, right, configuration files, when you run this Terraform validate, it will check whether these configuration files are syntactically correct and internally consistent. But it does not contact the cloud provider and does not check if resource actually exists. So when you run this Terraform validate, it will not contact any of these cloud providers to check whether the resource is there or everything is correct. Uh, Provider details are correct. All these things it won't check. It will just check the um, syntactically whether the configuration files are syntactically correct or not. Then the third point is it only validates your Terraform codes. Okay. So that is about the Terraform validate and when to use it. So we need to use it before we actually run the Terraform plan. So this is the flow, Terraform workflow. The first one is Terraform init. We will initialize first, then we'll validate to check whether the configuration files are syntactically correct. Then we run the Terraform plan. Then we run the Terraform apply. Last one is for destroy. That is a different part where if you want to decommission the resources, then only we use this destroy command. But basically, one, two, three, four. These are the four commands which we use to create the resources on Azure or on-premise using the Terraform. We use this in CI/CD pipelines to validate our configuration files. The third point is after editing variables, modules, or providers. So when you are trying to make modifications in your configuration files, then we use this Terraform validate command. So it basically helps to catch simple mistakes early before you actually run the Terraform plan. So that is about Terraform validate. The next command is the third command, that is Terraform plan. So Terraform plan, what is Terraform plan? It shows what changes Terraform will make to your infrastructure before applying them. So plan will show you, okay, these are the changes which you are going to make. So that output it will show when you run Terraform plan. You can think of it as a preview or a dry run to ensure the expected changes are correct. And it does not create, update, or delete resources. It only shows the execution plan. That is the third point you should remember. So how it works, the flow is like this. First, it will read the configuration files. When you run the Terraform plan, it will read the configuration files. That means it will check the .tf files in your project. The second step it will do is reads the current state, local or remote backend state. We'll be covering this state file in detail. Right now, you understand this. There will be one state file where some details will be there uh, about the resources which are already there in on the cloud. The third step is calculates the changes. So it will calculate the changes, what is already there, and what extra you are making changes. Like, are you going to create or delete or update? So it will calculate those changes. So it will determine what to add, update, or destroy. So that is the third thing it will check. And the fourth part of this one is it will display plan to users, shows actions before applying them. So when you run this Terraform plan, at the end, it will show, okay, these are the actions it is going to take. So, so this is what it will do during Terraform plan. The fourth command is Terraform apply. So Terraform apply is the command Terraform uses to provision, update, or modify infrastructure based on your Terraform configuration files. So we run this command after Terraform plan. In the Terraform plan, we were just trying to understand what all the changes my configuration files are making are going to make the changes on the cloud. Okay, but in this command, it will go ahead and actually applies them. That means it will go ahead and create or update or modify the resources which my configuration files want to do. So it takes the execution plan. The second point is it takes the execution plan and applies it to the target cloud or platform using provider APIs. Think of it as a make the changes real. So this is where we actually apply the changes. The flow will be like this. So when you run this Terraform apply, it will read the current state. So determines what exists in cloud. Second, it does is evaluates configuration, compares a decide configuration with the state. And the third point is executes changes. It creates, updates, deletes resources, and it will at the end it will update the state file and tracks the real world changes. So this state file we have a separate class as I mentioned earlier. So we will be covering in on the fourth day. So that will be a um, that will be a good class to understand what is the state file and how do we manage these state files. So right now you just understand there will be a state file where we'll be tracking the changes. So the last command of these basic commands is Terraform destroy. So this is used when there is a request to decommission the resources and all. So Terraform destroy is the Terraform command used to delete or destroy all infrastructure resources that were previously created using Terraform. So it will read the state files and removes everything Terraform manages. Think of it as a teardown or cleanup phase of your infrastructure lifecycle. So how it works? So first it will read the configuration and state file, understands what resources exist, it shows a destroy plan. It will show us, okay, these are the resources it is going to destroy. Then it will ask, do you want to go ahead? Then if we type S, then it will go ahead and start deleting the resources via provider APIs. And at the end, it will updates or cleans the state file. So these are the basic commands: Terraform init, initialization, Terraform validate, Terraform plan, Terraform apply, Terraform destroy. These are the basic commands which any Terraform user should know. So we'll be using it day to day, and we should know each one of them, why we are using this, and what is the functionality of these commands. Any questions on this before we actually go ahead? Okay. Uh, I hope you understood that, and we'll be seeing how these commands work in the lab. So we'll be seeing more on that in the lab. So right now I'm covering this part where I will be explaining you how a resource block will look. How do we declare that? So inside this blue box, right, I have declared a resource. So resource, when I'm declaring a resource, that means I wanted this resource to be created on the cloud. It can be a resource group, it can be a VM, storage, anything. So we'll be declaring like this in the Terraform configuration files. So here in this blue box, I have declared a resource group which I wanted to create in my Azure cloud. So the first one, it begins like this, resource. In the bracket, it says Azure RM underscore resource underscore group and my RG. And then inside this brackets, I have name. So these are key values. They call it arguments. So when I run this, I'll be creating a resource group, my RG, that is the name of the resource group, and location is West Europe. We call this arguments. So there will be a question on basics. People will ask you, what is the argument? Then you should be able to you should be able to explain this. Okay, so these are the key value pairs which we'll be declaring inside the um, resource block or any of the blocks and arguments. Okay, and the first is like this resource. This is the block name. We call it as a block name. And then this is a resource type, Azure RM underscore resource group. Azure RM is provider, resource is resource group. We will be declaring like this. And resource name is my.rg. This you can change. Whatever the name you want to keep for this block, you can keep that. This is the resource name, and these are the attributes. This is how we declare a single resource block. Block name, resource type, this is resource type, this is resource name, these are arguments. There are different blocks in Terraform. In this particular table, you are seeing different blocks and the purpose of the block. So Terraform configuration is structured using different types of blocks. So when you take the Terraform configuration files, it is structured in such a way that it will have different type of blocks. Any configuration file you open, it will be having the blocks, any of these blocks, each serving a specific purpose. Each block will be serving a specific purpose. Below are the main Terraform block types you should know, especially for interviews and real world usage. So this Terraform block, so when you declare a Terraform, so this will be a block name or a resource name like this. So here instead of resource, I can declare resource Terraform, or instead of resource, I can declare provider, data, variable, locals, modules, output. So here instead of resource, I can declare any of them. So this is the block name. So Terraform block will be used for version providers backends, and this provider block configure cloud providers. We use this provider block, resource block. We use that to create infrastructure. Data block we use to read existing resources which are already created in the Terraform. Then we use this block to read the existing resources. Variable block to input those parameters. We use this variable block, locals. So these are internal values, modules, reusable configuration, output, export values are after deployment. Don't get panicked that I'm showing everything in a single page. So we'll be covering each of these blocks in the next sessions. Okay, today we'll be seeing resource block. Tomorrow variable block in detail we'll be seeing. And sooner we'll be seeing data block, locals, modules, outputs. All these blocks we'll be covering in coming sessions. In detail we'll be covering, and we'll have the labs on each one of them. So this is about the different type of Terraform blocks. Okay, we'll go ahead with the lab now. Any questions on the things which we have covered so far? Different type of blocks.
I have one question, Ramesh.
Okay.
May I know the difference between variable and the argument?
See, variable and argument, right? Argument and variable are, I will say, almost similar. There is one more thing also, parameter.
Okay.
Basically, I will give you one example. Okay. Like you went to a Chinese fast food center, then you ordered a dish. Okay. So
Okay.
the chef is preparing a dish, like you have ordered, for example, um, veg Manchuria, right? What he has to do, he has to prepare that. But for that, he in the morning he goes and buys all the vegetables, all the things, right? Those are the inputs for creating that,
Mm-hmm.
correct? So these
Right.
variables, when you declare, right? If the dish changes, the variable changes. That means the ingredients will change, right? If it is a veg manchuria, the ingredients are different.
Right.
If it is a fish curry, the ingredients are different. So variable gives you an option to change the inputs you are passing to that.
Okay.
Okay. Arguments are also like that. It allows you to change the inputs. Okay. So generally, these, right, when you use a function, we pass it as a parameter. And to the parameter, we pass it as a variable from the
Oh,
actual, when you call that function or like that.
right.
Yeah, and these arguments generally what I have seen, you pass it at the end, hyphen argument, then you give the key value, key value. So of most of them are same only, where at the end it goes as an inputs to the function. Like
Mm-hmm.
here as an input to your dish.
So in resource block, we are using the argument, right?
Correct. Yes.
Uh,
So these, right, uh, tomorrow we have these variable sessions. We declare them
okay.
as a variables. These
Okay.
this value, right? This is a key,
Uh-huh.
right? This is a value. This value we'll declare as a variable. And these are arguments, key value pairs. But
Key
variable is
value pair
just
together is argument, right?
correct. And this is
Okay, got it.
yeah, this value we will be declaring as a variable.
Very good. Yeah, got it.
Yeah.
Thank you.
Uh, Ramesh, what are the scenarios if we have to use multiple Terraform blocks, right? For example, we use mainly the resource block to create the infrastructure resources, right? So, what
Hmm.
are the scenarios where we use multiple blocks, data or resource or output or whatever it is? What are the major scenarios where we use multiple blocks in one main TF?
Okay. So thing is when we use a Terraform code, when we use this Terraform code, like I want to build an environment, a architecture or infrastructure for my entire project. Okay, it has a resource group, it has application gateway, it has app services or VMs, it has a key vault, it has a storage, it has a VNet, it has subnets, everything, right? So during that time, what we do, we declare everything in one block. Okay, and Terraform and provider are like, you pass these authentication and authorization details here to connect to the um, Azure cloud. Resource
Mhm.
block is the new resources which you want to create. Then you will put this as a resource block. Data block is like, already there is a network thing. They have created a VNet. Then you have to use it. Okay. So then what we do, they gave you the details, which is already created. VNet is already created. Then use this data block. Similarly, variable block we use to parameterize things. Locals also will be using modules is so in main of most of the Terraform files we use the modules, not the resource block. Okay, because what we do, we generalize everything in modules. It's kind of a function or like that. We call them to create the resources. Outputs are like, some output has come, then I want to reuse it to create the another resource. Okay, we'll be covering in detail everything. Okay, I don't want to confuse you, but in
Okay,
coming classes, right, we use everything, all of these. At the end, you will be able to create one project.
okay, okay. Yeah,
Okay,
thanks.
but we'll use all the blocks.
Okay, yeah, thank you.
Yeah. So right now, we are just in the beginning on the basic commands. Okay. So we are using these commands, how these commands work, we'll be seeing. Okay. The first lab today is, this is the lab I have planned for today. Resource creation on Azure cloud using Terraform. So I'll go back to my Visual Studio Code. Okay. I just have main.tf file. It has a Terraform block, provider block, then these resources I have planned, and just one notes I've created just to show you. These are the commands which we just covered. This is the only file I have. Right now, what I will do, I will take this off from here. Okay, and I'll create one more file. I will say providers.tf. I'll cut. Just want to make sure the code looks clean. So I copied and pasted the Terraform providers block here. Then I will go ahead and save it. So we covered yesterday that, all the TF files, when you run any of the Terraform commands, Terraform will pick all the TF files. Okay, these different files, right, in the root directory, it only matters for human that for easy readable. But when it comes to Terraform, it will pick all the Terraform files. It merges all of them into a single configuration file, and it will go ahead and run it. So I just kept the Terraform providers here in this providers.tf file to make sure the code looks cleaner. So I just have three resource blocks in this Terraform main.tf file. The first one is a resource. This is a resource group. Okay, I gave this name. I can change this name to something like org name is techlines hyphen. I want to create this for the dev environment. I give the name like this. So this will go ahead and create a resource group with this name, and the location is this. So now I want to create a VNet, and the VNet name is this. I will go ahead and change this name as well, like techlines hyphen dev VNet. And location, see, location I have declared like this. How you can declare the location? This will be like this. I just took it from here, from this block. So it is like, just copy like this, then dot name. Name is this key. If I want location, then I will declare like this. You understand? So this is the resource type, resource name. Then this is the argument key. Okay, so this is what I have declared here for location. So this is how I declared. And for name, it will be like this. So just change. Okay. I hope you understood how these two are declared. And this is the address space for my VNet. And similarly, this is a subnet inside my VNet. Then I will say declines and hyphen SN. SN is subnet. And it needs these values, resource group name and virtual network name. Virtual network name. So it has come from here. And the name. Okay, and address prefixes. So that means the subnet address space will be like this. Okay, and these three resources I wanted to create. I'll go ahead and save this. First on this, I will run Terraform init. So now it is initializing this folder, and it is trying to download providers and modules. So now you see the provider here. We don't have any modules which we need to download. And then I'll run Terraform validate. is the second command we generally run after Terraform init, just to validate whether my configuration files are syntactically correct. So go ahead and run the Terraform validate. So once you run this Terraform validate, you see this output. So it says success, the configuration is valid. So everything looks good. If there are any errors, then it will show errors. Like I'll just do like this and I will say, then let's see what happens. Terraform validate. So it will show error. Okay, at line number 5, it is coming out like this. We need to correct that. So this is how it shows. I'll save it back after correcting. Go ahead and run this Terraform validate again. So it looks good. Then the third command is Terraform plan. So we'll go ahead and run this. Let's see what is the output. So once you run this Terraform plan, so the output will look like this. It shows Terraform used the selected providers to generate the following execution plan. Resource actions are indicated with the following symbol, that is plus. That means create. So here Terraform will perform the following actions. So this one will be created. That means this resource will be created. Then this is a subnet. This will be created. Then this is a VNet. This will be created. Okay. That looks good. And at the end, you see plan 3 to add, 0 to change, 0 to destroy. That means 3 of the resources will be created. I'll go ahead and run. I'll go ahead and run Terraform apply. And here on the Azure cloud, let me check. I don't have any resource groups. Okay. It is asking, do you want to perform these actions? Terraform will perform the action described above. Only S will be accepted to approve. Go ahead and type S. So now it started creating the resources. It has created resource group. Now it is creating VNet, and it created VNet, and then it is creating subnet. It says apply completed, resources 3 added, 0 change, 0 destroyed. So I'll go ahead and check in my Azure portal, refresh. So I can see my resource group, tech clients dev RG. And inside the resource group, I should be seeing a VNet. And this VNet has this configuration, which I declared in my resource block, VNet resource block, then subnet. So I am expecting a subnet. Yeah, I can see it now. So this is the subnet which got created. I think Amar, he has gone, he joined Azure classes. And some of you, if you have gone through my Azure classes, we have created everything from the portal, a VNet, a subnet, and everything. But when it comes to automation, we use a Terraform. So right now we have created these Azure resources using Terraform. So this is how we create a VNet subnet resource group using Terraform. So now the last command is Terraform destroy. So We rarely use this unless until there is a decommission request, then only we use this. I'll go ahead and say Terraform deploy. Sorry, Terraform destroy, sorry. Terraform destroy. So it shows same like how when I ran Terraform apply, right? Similar output it is showing. But here, the thing is, here it is a minus symbol. It says destroy. Earlier it was plus and it was showing create. Now it shows minus and destroy. And it shows everything like what will be getting destroyed. Here, this resource group is getting destroyed, and subnet will be destroyed, and similarly the vnet will be destroyed, all these things. Okay, and it is asking, do you want to continue? Enter yes. So there is one option. I don't want this prompt. Like it is asking me to give input like as here. So in such cases, we can use something like this. So it has asked me why, when I try to apply, and it is asking when I'm trying to destroy. So I don't want this prompt. In that cases, in the command, you can keep it like this: hyphen auto hyphen approve, hyphen auto hyphen approve during destroy. So we use this because when I keep this command inside my CI/CD pipeline, I'm not going to that is not an interactive mode, right? That is non-interactive mode of creating resources where I don't come and type yes or something. Even when I run the CI/CD pipeline, it runs in the agent boxes where I don't have the access to the console few times. So, so this is how we do. We we write the command like this. We add hyphen auto hyphen approve. That means we are typing S here so that it can continue. So that's how this auto hyphen approve will be used. And anyhow, I just typed S here. I did not use the auto hyphen approve. So this will go ahead and destroy these resources. So far what we have covered is, I'm coming back to the list of topics which we are going to cover. I'm sure that, yeah, this got completed, and destroy completed, and resources 3 destroyed. And I come to here and check, I refresh. So the resource group is gone, and all the VNets and subnets which we created inside that are also gone. Okay, with this, we complete the lab for today. I just want to go back and show you the topics which we are going to cover. So far what we have covered, we have done the first one, introduction and basics. We have covered the providers yesterday, then the CLI workflow we have covered today. Init, plan, apply, destroy, we have covered today. Tomorrow we'll be covering Terraform variables. Okay, and we'll be also seeing outputs and locals in the coming classes. And most probably on day 4, the plan is that I'll be covering state management, state log. How do we manage the state files and all? What is a state file? How do we manage that? And some commands related to state management, Terraform import, pull, push, will be covering on day 5 or day 6. Then in the next week, we'll be covering modules and workspaces. What are modules? How do we create modules? Where can we use modules? How we can use these modules to create the resource meta arguments. Count for each depends on why do we use these meta arguments. We'll be seeing in the next. So this is planned for next week. Life cycle rules also planned for next week. Dynamic block is one of the interview questions generally people ask. So we'll be also covering that in the coming classes, and these are all planned next week. Provisioners at the end. So from most probably all this will be covered in the next week. And in this week, we'll be covering variables, outputs, locals. Those are the blocks. And we'll be also covering state management backends. Locking also we'll be seeing. Okay. So this is the plan. And going back to here, we have done day two as well. Then the overall summary is that what we have covered today, we have covered the Terraform basic commands. We have seen what is Terraform validate. We have seen Terraform plan, Terraform apply, destroy, and we created resources using Terraform on Azure cloud. Yeah, with this, we complete today's session. Are there any questions before we wrap up the class?
Ramesh, I have a question.
Yeah,
When we run this Terraform destroy, it tried to destroy all the infra which we created using Terraform apply. So what if
correct.
we wanted to destroy a single resource? How do we do that via command? Let's say
Yes.
we only wanted to delete a subnet.
Yeah, good question. So the requirement is that we just want to delete a subnet, or I just want to delete a VM. I'm no longer using that. In that case, we use one command. So basically, you are targeting that VM or the subnet to destroy. So we have a command where you can pass a argument -target equal to, you give the resource ID like that. Then you run the command Terraform space destroy space, and you pass the target, and run it. It will destroy that resource alone. Similarly, the apply or will also work. Plan also.
Yeah, okay, Ramesh, thank you. And
Yeah.
also, is there a way we can, implement RBAC on this Terraform? Every person doesn't needs to have this Terraform destroy access, right? Or the
Mhm.
create access.
Yeah, so we can also implement RBAC rules using this Terraform.
Okay,
So yeah, we can do that. Uh, you just there will be a block you need to declare, then
okay,
run that, then it will go ahead and apply those changes.
thank you.
So those are little advanced topics, but you can do some research after um, after these next 2 or 3 sessions. You will have a little more clarity how they are working, how we are declaring, and all.
Okay, Ramesh, I
Yeah.
understand. Thank you.
Yeah.
Yeah, usually in the real times, they use the RBAC policies only. So you'll have the privilege group users who can only access, and they'll grant access to either create or to modify or delete. So it's completely based on the RBAC only. The
Yeah.
most of them don't have full access for these repositories at all.
Yeah.
Yeah, just thought to give a point, sir.
No problem. Yeah. So I too like these sessions to be like interactive sessions, and it's like a conversation happening. Okay, because I know some of you are working professionals, and I know some of you have a good experience on some of the topics. So please feel free to pitch in. I will be happy, if the audience are receiving the more information from the participants.
Sure,
So
Ramesh.
Ramesh, while creating that lab, right, while creating the resources, I have seen that there are state files is being created. Are those the state files you are going to be mentioned?
Yeah, state file. I did not I just did not show you or mentioned anything about this. These will get created when you apply this. Okay, state management will be covering on day 4
Okay.
in detail. What it has, what are local state files, and how do we maintain the remote state files. Will be covering on day 4. We have a
Okay,
separate
Ramesh.
class on state management.
Sure. Yeah. Thank you.
Yeah, no problem. Okay, then I think it's 8:40. I'll give back your 15 minutes. 8:45. I'll give back your 15 minutes. Yep. If there are no questions, we can wind up. Anyone has any
Thank
questions?
thank you, Ramesh. I don't have any.
Okay. Okay, then thank you all.
Thank you,
Thank
Ramesh.
you, Ramesh.
Happy
Have a good day.
Tuesday. Bye.
Thank you.
Thank you very much, Ramesh.
No problem. Yeah, thank you.